77 when we're done. Okay, we're going to be graphing logarithmic functions, and which, again, should not be brand new. We're going to look at how to graph it a couple of different ways because you need to understand both. Which one you actually do, I don't really care. It's up to you, but you need to make sure you understand how they all work. So a log function basically can look like this. F of x equals log base b of x. So b is the base. Things we should already know about logs are that they are the inverse of an exponential function. All right, so it says using your graphing calculator, but we don't need to do that. Because you need to know what these look like without one. When you rewrite these, like rewrite a log in exponential form and vice versa, you are not actually writing the inverse. And sometimes people get that confused, like you feel like you're writing the inverse and you're not. To actually write the inverse of a function, what do you have to do? Good. You exchange the places for x and y. There you go. Exchange the places for x and y. So if you don't actually do that, then you don't have the inverse. If I take this and I want to write it in exponential form, f of x is just going to be y so that I can do that. The base here is what? 10. So this is going to be 10 to the y power equals x. And if I rewrite this one with a y, that would be y equals 10 to the x. So they look very similar, but they're not. The reason they're inverses is because x and y is switched. Just because I write this one in this form, I'm not writing the inverse. Okay, we're all clear on that? Because that sometimes is a little source of confusion. We've been graphing this one, so we should be able to graph this just fine. Where is this asymptote? Nowhere? We don't have an asymptote here? Y equals 0. Okay, so we got a y equals 0 here. My y-intercept, when x is 0, what is y? 1, right? So there's your y-intercept right there, right? Which means that this little graph looks something like this. So since this is the inverse, where's the asymptote? X what? X equals 0. X and y switch places, right? So this is, thank you. So this is going to be at x equals 0. Way too many of you, I mean enough that I noticed it and it just started to make me a little sad. On the test when you had to graph a basic exponential, you had it graphed correctly, but then you wrote that the asymptote was x equals 0. I know you know the difference. You just have to make sure that you process it through your brain and write it down correctly. Because, I mean, some of the people that were doing that wrong, I know you know, but, when you do things quickly, sometimes we don't think 100% through it. So this is x equals 0. This is y equals 0. All right, so then I don't have a y-intercept, obviously, but I would have an x-intercept. Where would my x-intercept be? At 1, right? If this here is at 0, 1, and this is the inverse, this is going to be at 1, 0, right? Remember that the inverse is just a reflection in the line y equals x, right? So if I just reflected this whole thing in the line y equals x, then my asymptote gets flipped up, and then this point gets flipped down here. When y is 1 here, what is x going to be? When y is 1 on this one, x would be 10, right? When y is 1, x is 10, yes? So if I think about that, when y is 1, x is 10, I'm like way out here, plus it's the inverse of that. This graph looks something like this. Okay, so those are your two basic parent functions of logs and exponentials, and they are inverses of each other. The easiest way to graph logs without a calculator and understand where everything is to put it in exponential form. Not really do the inverse necessarily, but just write it in exponential form and go from there. We're going to do that and look at it in a different way as well. But we're going to just graph some basic parent functions without transformations first. So here's this first one. I have f of x equals log base 3 of x. So the first thing we're going to do is just rewrite it in exponential form. So this would become 3 to the y power equals x. Everybody with me? And then we're going to make a little t-chart, which if there's 0 transformations, you may not always feel like you need to do that. But when transformations come into play, I highly suggest you do. Not because it's complicated to figure out, but because it's very, very easy to get things backwards and mixed up. Like the numbers are simple, but it's so easy just to get them mixed around. So I'm going to make myself a little chart here. And instead of choosing numbers for x like we normally do, we're going to choose them for y. We don't usually write this out when we're doing parent functions just because it's easy to kind of find. But again, since we're having to think backwards, it's kind of helpful. So we're going to choose -1, 0, and 1 for our y every single time. So when y is -1, x would be what? 1/3. When y is 0, x would be 1. And then when y is 1, x would be 3. Okay, that makes sense? Since there are 0 transformations, I know that my asymptote is at x equals 0. So asymptote is at x equals 0. And again, since there's no transformations, I know that my x-intercept is at 1, 0. Okay, those are a couple of things that I know from the get-go. Then I go and I can plot these other points. So when x is 1/3, y is -1. When x is 1, y is 0. I already had that one. And then 3, 1 is another point. So before I sketch my graph in, I want to make sure I have my x-intercept graphed, which I do. Since these don't have transformations, that'll happen before we do anything else. And then I can draw in my graph, and it looks something like this. My domain goes from 0 to infinity. The range goes from -infinity to infinity. Are there going to be any transformations that are going to affect my range? No. Okay. So no matter whether I stretch it and translate it, whatever, compress it, my range is still -infinity to infinity. So this is going to stay the same no matter what. My domain can change. That's the opposite of what was happening with exponentials. Okay. It is increasing through the whole graph, or the whole function that's graphed, but that means it's starting at 0 and going to infinity. It's not increasing any. I wrote this out for you, and last time I did that, I messed up, and then I copied and pasted from the same thing, knowing I was doing that and reminding myself to fix it, but I still didn't do it. So as x approaches infinity, f of x approaches infinity, right? And then this should say -infinity. But at the same time, it really doesn't. This was one of those kind of weird ones when we were doing parent functions. X can't approach -infinity. It's not going to get past 0, right? And so we haven't really gotten into limits, so this isn't really the best way to say it, but I can't really get into the other stuff either because we're just not there yet. So really, as we think about it, this should be as x approaches 0 because that's where my limit's going to be. But either way, when I'm going to the left as much as I can, f of x is going to approach -infinity. Okay? Everybody okay with that? Easy enough? And I feel like maybe with the parent functions, you don't necessarily need the little t-table. You can figure out the points on the graph, but you'll need them later. So we're going to go ahead and continue to do that. All right, so we're going to rewrite this one as a parent function. So this is going to be as an exponential function, 1/2 to the y power, but that 1/2 has to be in parentheses. Otherwise, it just looks like it's the 1 to the y power equals x. Then I'm going to make my little table, starting with -1, 0, and 1 for y. So when y is -1, what is x? 2. When y is 0, x is 1. And then this would be 1/2. So again, very simple to come up with every single time, but jot them down so you don't do anything weird. My asymptote is here at x equals 0 because there are no transformations. My x-intercept is at 1, 0 because there's no transformations. I may have to think a little bit about those two things if I've got some transformations going on, but I don't. So I also know I have this 1, 0, which is also in my table. So then I can graph the other ones. X is 2, y is -1, x is 1/2, y is 1. And I already had that 1, 0 on there. So then when I draw this in, looks something like that. So my domain for the parent functions is going to be the same. It's transformations that could change that. They go from 0 to infinity. Range is -infinity to infinity for all of them. Is it increasing anywhere? No. It's decreasing from 0 to infinity. Because remember, those intervals are always x's that you're writing. Then as x approaches infinity, f of x approaches -infinity. And as x approaches -infinity, or really 0, then f of x approaches infinity. So if you look at these two together, these two are examples of parent functions of logs, This is when your base is greater than 1. This is when your base is between 0 and 1, which is just a reflection on the x-axis. The other. Okay? Everybody good with all that? Any questions? All right. Let's do one more parent function, and then we'll move on to the others. All right. So f of x equals the natural log of x. So we're going to rewrite that in exponential form. What's the base here? E. E to the y power equals x. Come in. And then so e to the y power equals x. So I'm going to choose -1, 0, and 1. And when y is -1, e to the -1 power would be like 1 over e. What is that as a decimal? About what? 0.36 something? Yeah. 0.36 blah, blah, blah. And when y is 0, what is x? 1. I do not. I looked. I don't have any. All right. Then when y is 1, e is about what? 2.7. And those, knowing them just to those two numbers is enough, but always put ... because that's not the actual value. I don't want you to ever think it is. I don't want you to imply that it is. But that is good enough to graph on these graphs. Okay? And good enough to get the, the idea of what's going on. All right, so then this is still a log function, so my asymptote is still at x equals 0. My y-intercept, since there are no transformations, is still at, my x-intercept is still at 1, 0, which is also on my little chart. So then when x is about 0.36, y is -1. When x is about 2.7, y is 1. I've got my x-intercept in there. So then when I draw this in, got that. Okay. So domain, no transformations, so it's going to be 0 to infinity every time. Range, -infinity to infinity. Increasing, 0 to infinity, not decreasing at all. As x approaches infinity, f of x approaches what? Infinity. Well, infinity. There we go. And then as x approaches -infinity, or really 0, because that's as far as we can get, it approaches what? -infinity. Okay. Everybody good with that? So we can totally graph the parent functions, yes? All right, so let's look at transformations. We're going to look at them a couple of different ways. We're going to start off by looking at them kind of the exact same way we just did these things. We're going to write our parent function in exponential form. So I didn't label it as parent in the other one because that's all it was. I don't care about the transformations right now, just what would the parent function be in exponential form. The base is 1/3. I would take that to the y power, and that equals x. That's just the parent function, right? Then I'm going to make my little chart, just like I did on the other ones, from the parent function. So -1, 0, and 1. When y is -1, x would be 3, and then 1, and then 1/3, right? Then I'm going to write down what my transformations are. What's the only thing that's happening here? Okay, translate up 1. So we're going to translate up 1. All right, so what transformations are going to affect my asymptote? X, what going on with x though? Just the translations, right? The compressions and the stretches aren't going to affect it. The vertical, anything isn't going to affect it. It's just the horizontal transformations, and we don't have any. So since we don't have any of that, my asymptote is in the exact same place. So this is still at x equals 0. And then we'll go ahead and plot some points and then decide if we need to figure out what our x-intercept is. So what we're going to do is we're going to find where these points are. I'm not plotting them, but I'm going to find where they are. And then from there, I'm going to do whatever my transformations are. So when x is 3, y is -1 for my parent function. My translations are to translate up 1. And boom, there's my point. Well, that's my x-intercept. That's 3, 0. Then when I'm at 1, 0 for my parent function, I'm supposed to translate up 1. I'm right there. At 1/3, 1 for my parent function, I translate up 1. There's my new point. I have my x-intercept plotted. I have at least 3 points on my graph. Then I can draw in my log function. Something like that. So my domain isn't, if I have transformations, it isn't guaranteed to be 0 to infinity, but it is here. So that 0 to infinity, range is going to be the same every single time. It's not increasing, it's decreasing, and it's going from 0 to infinity. So as x approaches infinity, f of x approaches negative infinity. As x approaches negative infinity, or really 0, f of x approaches infinity. Okay, everybody good with that? Ask me questions if you got them. All right, let's do one more that way, and then we'll look at it a little differently. So we're going to start by doing our parent function in exponential form. So this is going to be 2 to the y power equals x. Then I'm going to make my little table, which again, I know the numbers are very, if you don't write them down, it's so easy to get things backwards. So -1, 0, and 1. So this will give me 1/2, 1, and 2. My transformations, what is this negative going to do? Good. It's going to reflect in the x-axis. And then that 2 is going to translate where? Right to. And that's the only things I've got going on. So since is my asymptote affected here? Yes. This translation right to, which means my asymptote, which was at x equals 0, gets shifted over 2. So it ends up here. And my asymptote is at x equals 2. So let's plot these points, see if we got our x-intercept in here. When x, for my parent function, when x is 1/2, y is -1. So then I'm going to reflect that in the x-axis and end up here, and then translate to the right 2, and I'm right there. When x is 1, y is 0 for the parent function, reflecting in the x-axis doesn't take me anywhere, and then I translate to the right 2. That means that is my x-intercept at 3, 0. Then 2, 1 for my parent function, I reflect in the x-axis and translate to the right 2, and I end up right there. Okay. So I've got my 3 points, and that includes my x-intercept. Then I can draw in my graph, which looks something like that. My domain now starts where? 2. Goes from 2 to infinity. Do I include the 2? No. My range is still -infinity to infinity. My increasing interval, it's not increasing. It's decreasing from where? 2 to infinity. Good, because it's always my x's there. As x approaches infinity, f of x approaches -infinity. And as x approaches -infinity, which is really -2, just start kind of thinking that way, that I'm really just approaching I'm sorry, not -2, I'm approaching 2, then f of x is approaching infinity. Okay, everybody good with that? Any questions at all? Okay, let's move on to the next page, which will go on 78, I think. Is that right? Okay. And there's not a place for it, so you can just write it up here. So we're going to graph this one the same way, and then we're going to go back and look at something else with it. I'm going to write my parent function in exponential form, which means that would be 4 to the y power equals x. Then I'm going to make my little table. -1, 0, and 1. So when y is -1, this would be 1/4 and 4. Okay, very simple every time, but just so you don't get your x's and y's mixed up and your fractions upside down, just write them down. Then I'm going to write down what my transformations are. These are really just 2 translations, right? I'm going to translate where? Left 5, down 2. So does any of that affect my asymptote? Yes. Left 5. So that means 1, 2, 3, 4, 5. I got to go to -5 and draw in my asymptote. So x equals -5. So then I'm going to find my parent function points, but then do those transformations. So when x is 1/4, y is -1. That's for my parent function. Then from there I go to left 5, 1, 2, 3, 4, 5, and down 2. And I end up right there. I start at 1, 0. I go to the left 5 and down 2. Go to 4, 1. Go to the left 5 and down 2. Okay, so now what's missing? My X intercept. So I didn't just happen to end up on it like I did on some of the other ones. So I have to go find it. How do I find an X intercept? Y equals 0. Okay, good. So that means that I'm going to have 0 equals log base 4 of x plus 5 minus 2. Then I got to solve for x, right? So I'm going to add 2 to both sides and get 2 equals log base 4 x plus 5. Now, at this point here, I can rewrite it. I can't rewrite it here because I have 2 terms. I have one big term, one big log term here. So now I can rewrite it in exponential form. So this would be 4 to the what? 4 squared equals what? X plus 5. So this is 16 equals x plus 5. So x equals 11. So your x-intercept is 11, 0. Okay? So the graph only goes to 10. If you go just right about there, that's about 11. So you can get it drawn in there, right? And then I can draw this in. Something like that. My domain goes from -5 to infinity. Range is always -infinity to infinity for logs. It's increasing from -5 to infinity, not increasing at all. Notice for exponentials and logs, it's either one or the other on every single one of these. On other things we've graphed, we've had maybe something in each, but that's not what's happening here. As x approaches infinity, f of x approaches infinity. And as x approaches -infinity, or really -5, then f of x approaches -infinity. But let's look at a different way to do this. Let's look at how we could find our points before we ever even graphed anything. So this is our parent function points, but these translations are doing something to my x and y values. So what I'm really looking for here is not x and y, but when I'm going to the left 5, that means every x value is having 5 subtracted from it. When I'm going down 2, it means every y value is having 2 subtracted from it. So these are my parent function points. If I take this x value of 1/4 and subtract 5, that's going to give me -4 and 3/4. You agree with that? Take that 1 and subtract 5, that's going to give me -4. 4 subtract 5 gives me -1. -1 minus 2 is going to give me -3. 0 minus 2 is -2. 1 minus 2 is -1. So if we look at these points, if I go to -1, 2, 3, 4, and 3/4, and then -1, 2, 3, that's that point right there that I already plotted. -4, -2, that's that same point. -1, -1, that's that same point. That make sense? So you need to understand how to get your points both ways. I'm fine with you just graphing it all from the parent function and understanding how it works, but you need to understand what's happening with the values as well, because you can be asked questions different ways, and so you want to make sure you at least recognize it and can handle it. Okay, we all good with all that? All right, good deal. Let's look at the next one. We're going to do the next one that way. We're going to actually find those points and then plot them. So you still start with your parent function in exponential form. 1/2 to the y power equals x. And we're going to make our little x and y chart. -1, 0, 1. So this should be 2, 1, and 1/2. That should be like really quick for you to be able to come up with. Then we look at what our transformations are. That negative here with this x means I'm going to reflect where? In the y-axis. And then the 3 means I'm going to translate what? Up 3. So before I graph anything, I'm going to look at what's happening with x and y. Well, because I'm reflecting in the y-axis, that means I'm just changing the sign on every x value. So really, this is supposed to be -x. I'm translating up 3, so this should be y plus 3. So I use these values here. All these, I just have to change the sign. And then I add 3 to these, so negative 1 plus 3 is 2, and then 3, and then 4. So when I go to graph these, I still have to decide whether or not my asymptote has moved. Where's my asymptote? It's stayed at x equals 0, right? It's still at x equals 0. So it's still here. Then I've got, so to plot these points, negative 2, 2, negative 1, 3, negative 1/2, 4. So if we just look at the transformations instead, kind of, if I started at 2, negative 1, at 2, negative 1, if I reflect in the y-axis, I'm here, and then I move up 1, 2, 3, I'm right there. If I started at 1, 0, I reflect in the y-axis, translate up 3. 1/2, 1, I reflect in the y-axis, and I translate up 3. I get the same points either way, okay? And that's kind of the point of that. But what am I missing? My x-intercept. So 0 equals log base 1/2 of negative x plus 3. So I subtract 3 from both sides, so I get negative 3 equals log base 1/2 of negative x. So then I rewrite that as 1/2 to the negative 3 power equals negative x. So what's 1/2 to the negative 3 power? 8. So 8 equals negative x, which means, 8 equals negative x, so x equals what? Negative 8. So negative 8, 0 is your x-intercept. At this point, right there. Now I have enough to graph it. Something like that. What's my domain on this one? Good. Negative infinity to 0. My range is still negative infinity to infinity. It's increasing from negative infinity to 0, and it's not decreasing at all. As x approaches infinity, or as x approaches 0, f of x approaches infinity. And as x approaches negative infinity, f of x approaches negative infinity. Okay? Everybody okay with all that? Any questions at all? All right. Then go ahead and start working on this next one while I pass out your homework. So once I get that far, what am I missing? My x-intercept, right? So my x-intercept is going to give me 0 equals 3 times the natural log of x minus 1. So I can add 1 to both sides and get 1 equals 3 times the natural log of x. So I got some options here. That 3 can become an exponent on the x, but it's really going to be easier for me just to go ahead and divide and get 1/3 equals the natural log of x, which means when I rewrite that, what do I get? What's the base here? 1/3 power equals x. Now, do you know what e to the 1/3 power is? No, and I don't expect you to know, right? But e to the 1/3 power or cube root of e, that's the best we can do. It's just like if we get the square root of 5. We don't have a calculator. I mean, we could probably estimate something, but it doesn't even matter. My answer is just an exact form, so it's e to the 1/3 power or the cube root of e, comma 0. And it's not anything that I can graph on there at this point and feel confident about, and that's okay. Right? So then I can draw this in. Now I could take maybe kind of a wild guess at what it might be. Somewhere between 1 and 2. Would you agree with that? Then my domain goes from 0 to infinity. Range is still negative infinity to infinity. And increasing from 0 to infinity, not decreasing at all. As x approaches infinity, f of x approaches infinity. And as x approaches negative infinity, or really 0, it's approaching negative infinity. Okay? Now, what's one reason you may not have chosen to do the table here? Maybe you did, but why do you think a lot of people would just choose not to? Because of the weird decimals? Yeah. But does either one of these things affect my x value? No, so my table would actually look like this. My x's are just my x's. They're the same. 0.36, ... 1 and 2.7, ... My y's, I have a vertical stretch by a factor of 3 and I translate down 1, so that's 3y minus 1. 3 times negative 1 is negative 3 minus 1 is negative 4. 3 times 0 minus 1, 3 times 1 minus 1. And if you go and check those, 0.36, negative 4, you're right there. 1, negative 1, 2.72, same points. Okay, and those weren't so bad. I agree. If you do something with x, it may not be worth it, but just make sure you understand both ways. Okay, you can do it one way or the other, but make sure you understand them both. Okay, we good? Any questions at all? All right, go ahead and get those glued or taped in now, and you have quite a bit of time left to work, so make good use of that time and work.